let me see, who was not here yesterday? You were all here yesterday. Okay. So we're just doing, this is our last day before test review, okay? So we're going to review what we did yesterday. Today's assignment is just like yesterday, so if you understood it, great. If you're still struggling with it, you need to learn it today. It involves factoring. You have to be good at factoring, okay? And then Monday and Tuesday, one review to work on for 2 days. You guys will have 2 whole days to make sure you understand how to do all the problems on this test, and our test is Wednesday, okay? So, and also don't forget, today is the last day to take either one of these quizzes. So after the notes if you want to do it, if you want to come back later today, but by 2 o'clock, otherwise they just become zeros. One of them gets dropped, okay? If you have 2, or whatever one, your lowest quiz gets dropped. But make sure, if you have not taken these quizzes, that you come to me today. All right, so solving a system using substitution. And I'm making them pretty simple. I'm keeping them all like y equals y, so this equals this, okay? So what we're just going to do, and it doesn't matter what side you put either equation on, but set them equal to each other. Now, I hinted at it, but you already know from yesterday, you're going to have to factor, okay? When you factor, you always want your a value to be positive. We didn't have one like this yesterday. All of our x squareds were positive in front, so we moved everything to wherever x squared was. But since this is negative, I know I can fix it by moving over here, okay? So with factoring, you want a always to be positive. So I'm actually going to bring this x squared over to this side, right? That'll get rid of it on this side. And I'm going to subtract 20 from this side, which will get rid of it over here. Gives me a 0. That's what you always have to have. And subtract 20 from this side. So I have to put these 4 terms in the correct order. So I put x squared first, right? That's the x squared. Then I would do plus 3x, and then minus 18. So that's getting it in standard form where a is positive, okay? This is a quadratic trinomial. We call it the chart problem. But since there's a 1 in front, we're very happy. We love it when there's a 1 in front. It makes it so much easier. So we're asking ourselves, what 2 numbers multiply to get negative 18 and adds to get 3? Anyone? Just the numbers without the signs. What 2 numbers would we use? 6 and 3, right? You know you can subtract 6 and 3 somehow and get a 3. Right, so I'm going to go ahead and just put those there, and then we decide on the signs in this column, which one is going to be negative, my dears. And it matters, okay? There's only a couple different things that could happen. Try it on your calculator. Do I do 6 plus 3? Nope, that's not 3. 6 minus 3? Oh, there it is. Positive 6, negative 3. Make sure it works on this side as well. It has to match, and it does. And when there's a 1 in front, like we said, we get to go right to our factored answer, where we put the x's in the front, bring over plus 6 and minus 3. Then what? Set them equal to 0 and solve. Do I need to see that step? I don't need to. I'm showing it in case anyone still doesn't know how to do that. So I'm setting each of my factors equal to 0 and solving those. But you could do that in your head, I think. Now remember, this is our 2 x values. We need ordered pairs. So what we just found is the x value of each of the 2 ordered pairs. And now you can use either of your original equations and plug these each in separately and solve. So much easier to plug into this one, right? I'm just going to plug each of those x values in right there. So y equals 3 times negative 6 plus 2. I just put negative 6 in for x. That's negative 18 plus 2. So y is negative 16. That's one of my solutions. Then I'll do the same thing with the 3. Y equals 3 times 3 plus 2. And I get 11. So a lot of steps in these problems, right? A lot. And that was an easy factoring one, the short factoring we call it. Let's do one that has the long factoring so we can review. This is the type of factoring people forget the most. Even some of you yesterday were getting confused on it. Even some of my really good factors. Okay, remember, if y equals y, this equals this. So I can set 2x squared equal to x plus 3. Could I have written it the other way? Of course. Doesn't matter what side, which goes on which side. Remember, we want a to be positive. The 2 is already positive where it is, so we're going to leave it there and bring these two over to the other side. There's no like term, so I'm just going to put it in standard form. Remember, you always want to have a 0 on that side before you start. Right? This is a quadratic trinomial. Just like this one right here, these start the same way using the chart. The difference is that leading coefficient. Okay? So the two numbers that multiply to get, don't forget you're doing A and C. 2 times negative 3. 2 times negative 3. And B is negative 1. That's a negative 1 right there. And there's 1 and 6 or 2 and 3. I think you guys would agree with me that the only way to get a 1 is with these two numbers. Pick up your calculator if you need to. Which one is going to be negative to get a negative 1? The 3. It matters, but you can pick up your calculator, type it in. 2 plus negative 3 will give you a negative 1. If you tried any other combination, it wouldn't give you that. So we're happy here. Make sure we're happy here when we do that, and we are. Okay. So guys, listen. This is the step we're forgetting, because I held somebody back there. They've looked at it and thought of it like this type of problem. Like this type of problem. When there's a 1 in front, we get to go right to our factors. But because of the 2, we call this the long factoring. You have to bring down the outside 2 terms. Sign goes with it. Okay, so all I did is bring down those 2. And split the middle. I'm splitting the middle one into these 2 numbers, giving them both an x. It technically doesn't matter which one you put first, but it's easier if you put the negative first. And this is a good checkpoint right here. Does what I have in red equal what's above it in blue? Those 2 terms in the middle should equal negative x. And they do. Negative 3x plus 2x is negative 1x. Then we do 2 and 2. Chick-fil-A thing. What's the GCF of these 2? Sometimes it's a number, sometimes it's a letter, sometimes it's both. Just depends, okay? Do they have a number in common other than 1? No, just x, right? They each have 1 x in common. So we can just plot an x. Okay. You can check this. X times 2x is 2x squared. X times negative 3 is negative 3x. Now, here's another place I saw mistakes. You have to pull out a GCF. You have to. Even if the only thing they have in common is what? 1. And then that's the case. All they have in common is a 1. So I'm bringing this plus sign down. But it makes sense, because look, it matches these parentheses. So even if it's just a 1, you have to put it. And if you did it right, and we did, our parentheses should be identical twins. So that's one of our factors, right? The 2x minus 3 is one of them. And then the x plus 1. So when I set 2x minus 3 equal to 0, again, you could do this in your head if you're able to. Add 3, divide by 2. You could leave this one as a fraction or a decimal because it terminates. If it was a repeating decimal, I'd want to hit math, enter, enter, and go back to the fraction form of it. But either one of these is fine in this problem. And then x would be negative 1. These are both x values. And then you can pick either equation to plug in to get your y values. There are a lot of steps. Lots. Right, 1.5 times 3 is 4.5. Okay. So there is definitely going to be a long factoring on the test next week. So we have to know how to do this. We have to practice it. All right, so we're going to go to the same page as yesterday and do some. I'm going to do the first two with you, okay? Let's keep going together to make sure you guys understand those. Then I'll put the key up. If someone needs a quiz, feel free to see me unless you're coming at lunch or something. Today is it. No excuses. Okay. Is this one of the pages I had you guys rip out? Did anyone ever come up with that idea yesterday? If it was or not? Okay. It might not be. That's what number 11 looks like. They already set them equal to it for it. They didn't write y equals. That's okay. Thank you. They just did a step for us. Already set the two y equals equal to each other. Okay. So these problems are set up as if we just started right here. Okay, understand that. Just like they started there instead of writing this. Okay. Okay. All right. So we need to get everybody on one side. X squared is positive where it is, so everyone's going to come over to that side. Remember, sometimes when you bring stuff over, there's a like term to subtract from. Sometimes there's not. In this case, there is. 3x minus 2x is 1x, and 5 minus 7, negative 2. This is a chart, but the short chart is the 1. So 1 times negative 2, b is positive 1. There's only two numbers that multiply to get 2. 1 plus 2 does not equal 1, so we know we got to get some negatives involved. Who's going to be negative, 1 or 2? 1. Does it matter? Yes, of course. Pick up your calculator if you don't know. Love the shorter ones, right? When there's no coefficient. Hey there. What are you doing? All right, so remember, that's just the x values, and then you can plug into either side of the equation. Like 2x plus 7 would be the easier one, okay? So 2 times 1 plus 7 would be 9. Same thing, plug in the negative 2. Question on 11. I want to do one more long factoring with you. So guys, just understand, this means the same as if I had written y equals 9x, y equals 2x squared plus 4x minus 3, and then we go to this step where we set them equal to each other. Okay? So this is y equals this, y equals this, set them equal to each other. Okay? So we need a 0 on one side. We need our x squared to be positive. That means I'm going to bring the 9x over here. Okay, so 2x squared, then 4 minus 9 is negative 5. There's no GCF to factor out, which would make the problem a little bit smaller, so we know it's going to be one of our long factoring problems. A times C is 2 times negative 3. B is negative 5. And we need the two numbers that multiply to get 6, subtract to get, add or subtract to get 5. So it really could be either of these, right? Which one? Oops, I didn't make that a negative 2. Remember, we have to make both sides happy. So if we're going to use 1 and 6, the 6 would be negative, right? That would work. That would give me negative 5. Make the 6 negative here. Is 1 times negative 6 negative 6? Yeah, that's actually the answer. So let me just show you why this is not the answer. I would have to make them both negative, right? Negative 2 plus negative 3 is negative 5. But if I make both of these negative, I would get a positive 6. So that's why that could be the answer. Okay? It has to work in both columns. Okay, long factoring. Bring down the outside two terms, right? And split the middle. We split the middle into these two numbers, giving them both an x. It doesn't matter, but it is easier to put the negative first. Those two in the middle should equal negative 5x. And they do. Negative 6x plus 1 is negative 5x. Let's GCF it. The one we did a minute ago, they only had an x in common. But here they have a number and an x, right? 2 goes into both of those numbers, and they have an x in common. We divide that by 2x, we divide that by 2x. Just the reverse of the distributive property. You could distribute this and get what's right above it. What's the GCF of the second 2? Just 1. Yep. Sometimes it's just a 1. But look, my parentheses are the same. That's what's important. You should see that kind of, and it helps you say, oh, okay, I guess I did that right. Almost there. 2x plus 1, right? There's the hearts. I decided to do that first. Remember, it doesn't matter. And then the x minus 3. When I set this guy equal to 0, I will get subtract 1, divide by 2. Or you could do a decimal there. Doesn't matter, because it terminates. And this would be x equals 3. And there's a really easy place to plug into, guys. 9x, right? Y equals 9x and y equals this. So I'm going to plug into that one. That's nice and simple right here. So 9 times negative a half. I'm going to use negative 0.5. It's faster. I get negative 4.5. Or you can hit math, enter, enter, and make it a fraction. Either one. Either one. Negative 9 halves or negative 4.5. Okay? Okay. 13 is the only other one that has the long factoring. So you have one more long factoring to do. I did show all the steps, though, and the other two are easier factoring. Okay? plug it in where? Oh, yeah. Well, that's what I'm doing. I mean, but you have to know where to plug it, like what equation. But yeah, you can do the work in your calculator for sure. You want me to come talk to you? You want 15? Okay, I think I know what you're confused about. So let me just show you guys. Let me make sure you understand. In the examples that we did, it was y equals, but then what was the next step? We set that equal to that, okay? So the problems that we just did, or that you're seeing in the homework, skips this step and goes right to this. It sets it up for you. So, like, in number 11, it was given to us like this, but before it was that, it was y equals x squared plus 3x plus 5, and y equals 2x plus 7. It's just they already went to that step, okay? All right, it's just skipped. Yeah. All right, sorry.